Hi guys, let us derive one more expression, that is expression for energy density or energy per unit volume. So this is energy density, or that is supposed to be or per unit volume of a charged parallel plate capacitor. So this is a very small expression, but we need to recall all about capacitor. Suppose if you take a parallel plate capacitor, one is having positive charge and one is having negative charge, and they are separated by a distance d. Now this is the separation distance. Now if C is the capacitance and A is the area of the plate, and epsilon naught is the permittivity, and D is the separation distance. Now what we can write the expression for capacitance of a capacitor? So we can write the expression for capacitance of a parallel plate capacitor. C equal to epsilon naught A upon D. So this is the expression for capacitance of a capacitor. Capacitance C equal to epsilon naught A upon D. Now if you remember, so there is an electric field is exist between the plates, the electric field direction from the positive charge to negative charge. So between the plates the electric field is also exist. So what is the expression for the electric field? The expression for the electric field between the plates, we can write that electric field E equal to sigma upon epsilon naught. So here the sigma is the surface charge density. So if we can write that electric field, if sigma is the surface charge density, the electric field between the capacitor plates, the electric field between the capacitor plates, we can write electric field E equal to sigma by epsilon naught, or I can write the sigma equal to electric field times epsilon naught. So this is supposed to be epsilon naught, so I can write that as epsilon naught. So this is the relation between surface charge density times electric field and sigma. Now we know the surface charge density. What is sigma? Since sigma equal to what? Charge per unit area. Sigma equal to surface charge density, charge per unit area, which also equal to, I would like to write the charge Q equal to sigma times A. Now if you can substitute the second equations at here, so let it equation 3, therefore 2 in 3, therefore the charge q equal to E times epsilon naught times A. So this is the expression for charge. So this is the relation. So let me take as 4. Now finally, to derive the energy density, so if I can take the expression for energy stored, since energy stored in a capacitor, so energy stored U equal to half Q square upon C. If you can take this expression, you can substitute the corresponding Q value and C value at here. From fourth equation, I can write that Q of times Q square equal to E times A times epsilon naught square upon, and capacitance C equal to epsilon naught A by D. So that is the capacitance of a capacitor from equation 1. So this I can return from 4 and from equation 1. Now if we can simplify that, so that is the first equation, capacitance of a capacitor epsilon naught A upon D. If you can simplify that, the energy stored U equal to, this is only energy stored, so half times that equal to E becomes E square and A becomes A square and epsilon naught square upon epsilon naught times A times the D in the denominator I will bring to the numerator. So this epsilon naught, one of the square terms gets cancels, so I can get U equal to half E square times epsilon naught times AD. Now if you bring the AD term, so this term on the other side, so the energy density changes, so U upon A times D, which equal to half epsilon naught E square. Now here A is the area and D is the distance, or distance you can take. So area times distance, what we can write? We can write the volume. So this total term will be gives us volume. So we can write that U upon V equal to half epsilon naught E square. So U is nothing but energy per V, means energy per unit volume. So if I can write this in terms of words, energy stored per volume, which equal to half epsilon naught E square. So this is also known as energy density. So this we will take it as energy density. Therefore energy density we will represent that as small u, which equal to capital U upon V, which equal to half epsilon naught E square. The final expression I can write that U equal to energy density lowercase u equal to half epsilon naught E square. So this is the expressions we need to derive the energy stored, the energy density of a parallel plate capacitor.